I'm going to get started here. Thank you all for being here. My name is Dillon, and I'm going to spend the next few minutes telling you about our code smell detector project. So I don't assume that all of us are computer programmers. I'm sure for some of you there's nothing that sounds less appealing to you, but I know that we can all appreciate the idea that there are good ways of doing things and there are bad ways of doing things, or creative ways of doing things. In the world of code, you may or may not be surprised to hear that it's not divided into code that works and code that doesn't. Like many other things, it's more like a spectrum, with good code, better code, and some code that's maybe not so great. We could say that this code might even smell, which leads to the question of how can code smell? To begin with, it helps to understand that computer programmers spend a lot more time maintaining old code than they do developing new code. The way this code is designed initially has a huge impact on how easy or difficult it is to maintain further on down the line. And this brings us to our first main point about code smells. Code smells aren't bugs. They're symptoms of an underlying design issue. This design issue could lead to bugs later on, or more likely it'll just make things really difficult to extend upon by other programmers. So let's look at a small example of code smell. The only concept you need to understand for programming for this is the concept of a method, which is just a small reusable chunk of code that performs an operation. Now, this method just adds two numbers together. It's about as simple as it gets. Ideally, methods will each have one responsibility. This lends itself to easy understandability. But programmers don't usually work this way. Programmers like to jam all sorts of things into the same method until it does pretty much everything. It can work, but it's really difficult to understand and to work with. The solution, of course, is to split up the method into individual responsibilities per method. So what are we doing about this? The short answer is that we are looking to build an application that will analyze and annotate code wherever a code smell is found. When we're designing this application, we're keeping in mind that programmers like to use repositories. A repository is just a place where programmers store or back up their code files. One popular code repository is GitHub, which has about 20 million users, so we think it's a good candidate for integration with our application. This is about what our workflow should look like. We want the user to be able to log into our web application, choose which repositories they want us to scan, select what code smells they want to look for in their code, and then receive automatic notes on their code in GitHub. Now, how is this supposed to work on the back end? This is the more technical part. So, let's say one of our users has some great changes they want to add to their code in GitHub. They upload the changes to GitHub, and GitHub, in turn, sends a notification to our application that changes have been made. Our application requests those changes and downloads the code file. Once it has the file, it scans the file for code smells and sends information back to GitHub, letting GitHub know where those code smells were found in the file so GitHub can leave a note for the user to see. On the back end of our app itself, we're doing all the parsing using Ruby scripts. We just thought this would be the easiest way to do it. It also makes it easily extensible should users want to make a custom Ruby script in the future. That's the general idea of our application. But let's see a short demo. Oh, I'm sorry. To date, we have two detection scripts. We have a REST client for communicating with GitHub, and we have some basic file parsing tools that can be used in the creation of any scripts to make new code smell detectors. And here's our demo. Let's try that again.
This is a demo of our code smelling application. Now, I already have our command pre-formulated here, but I can step you through the different parts of it. So here we have a jar file, which is basically our application files all bundled together. And this argument this is where we specify what kind of code smell we're going to search for. In this case, we seem to be searching for methods that have too many arguments. These last two arguments have to do with reaching out to GitHub. So what's going to happen when I run this is our program is going to reach out to GitHub, try to log in with this username, and once we're logged in, it's going to request that GitHub give us the latest code in this repository, which is just named sample repository. So let's go ahead and run it and see what we get. Okay, so what happened here? We downloaded from GitHub the latest code files, which here we just see them as these temporary files with the .temp extension. And as we downloaded each file, we ran our Groovy script, which again checks for code smells. And then we apparently didn't get any results for some of the files, but we did get a result on this one. And what did we get? Again, we were searching for methods that have too many arguments. And apparently, this method in this particular file had a total of 5 arguments. We also have the line number of where that method is. The threshold right now is set for 3, so we're saying that if there are more than 3 arguments, that's too many. So again, this is just a demonstration of what our application did here was it reached out to GitHub, it downloaded the latest files from a particular repository. It ran the code smell detector that we selected on those files, and it gave us output of whether or not there were too many arguments in any of the methods, and it told us where they were. So what we're going to be able to do with this, as we continue to work on this, is to respond back to GitHub and say, hey, at this line number, there's a method that has too many arguments. Make a comment there. And then the user will see that comment in their code and will hopefully change their code. And that's what we have.
So the next steps for application, we need to build a web user interface so that people can select repositories that they want to be able to scan and select the code smells, run the application. We need to continue developing new code smells to search for, and we need to work on interfacing with GitHub to leave those comments on people's code that they scan. Thank you all for listening.